Welcome back to the Entrainment Workshop. Up next, we have Laura Bishop and Finn Upham, two local RITMOians, presenting Bodies in Concert. Take it away.
Thank you. That makes it sound, well, anyway. Okay, so Bodies in Concert. This is about a project that we conducted in February. It was a collaboration with the Stavanger Symphony Orchestra. They performed a series of children's concerts, and we measured the conductor, the performers, as well as the audience throughout these several sequences of performances. This talk is going to be sharing some of the patterns that we're observing as we dig into this data. This is a lot of different measurements at once, and we'll be focusing mostly on the performers in this time round. So here we see, for example, we have the conductor being measured, the body position, as well as eye tracking, and then the performers were wearing these physiological measurement devices that also capture body sway. So underneath their concert clothes are vests that were fitted to them, and the audience was also being tracked in their hand motion using infrared recording. But today we'll be focusing on these. So we also, by the way, for some sections of the orchestra, we were measuring the cellist and first violinist's bowing hand motion to be able to get very close to the action of playing for them as well. So first, let's take a little bit of a look at what the coordination is across the orchestra over repeated performances. So this is just a quick plot of the body sway of each performer during the repeated performances of a specific piece. This is the Radinsky march, and you can see per section we've got each person's body sway in time. And each row of these indicates sort of how much movement they're showing in time. And there's a couple things to notice in this kind of tartan pattern that we get in these plots, and that is that there's a lot of consistency in which sections are active when, which you would kind of expect, right? It's related to the action of playing. But there's also, particularly after the dress rehearsal, a lot of consistency in time as well between repeated performances. And that's because this is a professional orchestra playing music that they know, for the most part. And so their audio output, as well as their sort of physical action of performance, is very consistent from one performance to the next, which is fabulous, because that means that we have it almost like a control against which to measure fine changes and differences, and also internal systems that may or may not be quite as consistent as this. So one of the systems that we want to look at in relationship to performance is respiration. These are plots that are sort of the same nature as I showed before, but here yellow indicates when a particular performer is inhaling versus exhaling. And we have a different piece of music, and we see there's like a huge range of textures here, but there's also moments of alignment in particular sections that are repeated across performances. And that, for example, this is the brass players, and so yeah, we expect the respiration to be pretty well aligned to the music. But what is happening with everybody else? One way to look at this in combination is to actually, as opposed to doing this macroscopic thing, to focus in on how people are actually breathing as we watch it, to see what kind of patterns there are within sections, what kinds of alignments might be related to the musical action, or whether, for example, for string players, do they really need to be breathing in any way that's consistent at all? So here is a little visualization to help share with that. It's just the first part of a very interesting piece of music that we commissioned for this. And here, purple indicates when they are breathing out strongly. Green is when they're inhaling. And this visualization pours the present out is in the middle, and it carries the last 3 seconds of respiration. Indicates the sections going counterclockwise, so the conductors are the only one, and then the violin ones around. And the little dots indicate who is actually playing. Black dots, who is playing. Gray, who's about to start playing. So this will give you an idea of the breadth of information that is there in these performers' breathing as they are playing a piece of music like this. Okay, sorry for making your eyes feel weird. It's fascinating to watch this because there is such a combination of things that are clearly related to the music and things that don't seem to line up at all. because respiration is complicated like that. But there's some patterns of alignment that are important to point out. Obviously, there's the functional respiration of the winds, but in the strings and the percussion, we also seem to see instances where respiration seems to be aligned to musical actions. Entries, sometimes. And there also seems to be patterns of patches where across a section, for example, in the strings, they are aligned maybe for other reasons. And so we're interested in using this information to consider how respiration is maybe part of how people are coordinating their behavior. Now, that's across the orchestra. What about within players? Because we have all these recordings, we can align measurements from one performance to the next to see whether their bodies are in the same states at the same mind. So I'm just giving a little sampler of patterns that we're seeing here in body sway, respiration, and in heart rate features. So the body sway tends to be very consistent. Respiration for this string players, violin 2, seems to vary a lot actually from performance to performance. There isn't a locking into particular phase, but there are these striking moments of alignment in respiration phase with the music at specific. It's not totally locked, the same we might see in a wind player, but it is still repeating across performances. So it's kind of like phase related to the music and then not, and then phase related and then not. When we look at the heart rate information, it's startling that there's a lot of consistency from one performance to the next in the contours, but there's a huge range here, a big difference in beats per minute from one performance to the next. And that really suggests that there's a strong separation for these performers who are expert players, who do this all the time and are playing for a bunch of kids. It's not the most stressful situation. There is still quite a range of cardiac states that they are in while still having this kind of adjustment of intensity with whether you're playing or not. Last, we're trying to look at heart rate variability in a way that's related to the real-time action here. And in this case, we don't actually see a lot of consistency between performances. Yeah. Whereas, for example, for this cellist, the heart rate variability seems to have a concentration at this moment when they aren't playing. Now, we could go on about this stuff for quite a while, but just to give you an idea, this is what respiration alignment looks like in brass players. So it's a whole different category and for a bunch of different functions. Now, Laura can talk about the string players, some in particular.
You can keep that one. I have. Right, so Finn has been talking about interpersonal coordination broadly across the orchestra and also consistency within players across repetitions of the same music. At this point, we're going to narrow the focus and zoom in onto smaller periods of time and also look more specifically at individual sections of the orchestra, particularly the strings. So there's a great potential for actually very precise synchronization in the string sections, given that the people are actually playing exactly the same thing most of the time. Even though individual players, depending on where they're sitting in the section, can have very distinct perceptual experiences, both visually and acoustically. So in this part of the study, we're looking at synchronization in the bowing motion of the string players for cellists and violinists, and I'm just going to give you a little introduction to what we have been looking at with the cellists. So as Finn mentioned, we captured bowing motion data with an accelerometer placed on the right wrist of the musicians. Here we see a couple of examples of the data for small periods of time. On the left, this is an excerpt from an R-band piece, and we can see that in this case, the note density is very low, the motion is very smooth, and actually in some cases it's very difficult if you're looking at the curve to see where the notes actually start and end. This is in contrast to the example on the right, which is a passage from the Christofferson piece. Here we have a very different type of articulation. The notes are staccato, there's a higher note density, and it's actually very clear with this pattern of sharp peaks and troughs in the acceleration signal where the notes are starting and ending. Overall, it's not very easy for us to define the relationship between bowing motion based on the acceleration data and sound onsets. And here I would refer to the work of Anna Danielson and others on the Peace Center of these kinds of sounds that have gradual onsets. And particularly in this case, the relationship between the sound producing motion and the sound onsets is further complicated by the fact that the musicians differences caused by the use of different bowing directions and also different articulations. So one of the hypotheses that we're going to be testing with this part of the project is looking at the relationship between precision and synchronization and different aspects of the musical structure. So specifically, we would predict that precision is reduced when the rhythms are more irregularly timed, or when there are longer inter-onset intervals between notes, particularly without subdivision. The piece that we had commissioned for this project by one of the professors at the musicology department, Martin Christoffersen, this provides a particularly interesting context to look at this hypothesis, because the rhythmic texture changes quite a lot during the course of the piece. So how do we go about measuring synchronization in bowing motion based on accelerometer data? Currently, we're doing this in two ways. We're looking at group synchronization across the 5 cellists, in this case, who were the accelerometer. We're also looking at pairwise synchrony between pairs of cellists, and this gives us an opportunity to look at the potential effects of physical proximity, so those who are sitting next to each other versus not. For the measure of synchrony, since we tend to have this pattern of peaks and troughs in the acceleration signal that are approximately located where we would expect note onsets to occur, we find the midpoint between those peaks and troughs. We do this for all of the different players, and then for the group measure of synchrony, we take the standard deviation of the timestamps for those midpoints as our measure of variability or synchrony precision for the group for that note. For the case of pairwise synchrony, then it's just the temporal offset between the 2 midpoints. So here we can have a look over one excerpt from the squabble measure overture. In this particular excerpt of about 20 bars, the rhythmic texture changes quite a lot. So in the beginning section, I'll play it in a second. In the beginning section, the musicians are kind of alternating between having to match 6 notes to this 4-beat meter versus playing actually on the 4 beats. And then as the section goes on, the notes become further and further apart as the music kind of peters out. So you can see this in the vertical lines, or the estimated position of the notes here. I'll just play a very little bit so you can hear it. So you could hear that change in the rhythm. So what we're showing here in the bottom plot is the standard deviation per note across the 5 cellists. And we can see that there's this tendency to have larger asynchrony, so larger standard deviations in the parts like here, where you have these more complex rhythmic patterns, and also when the notes are more spaced out in the end, and it's more difficult to predict the timing. So trying to bring all this together a little bit, one of the things that we're going to be doing going forward is trying to bring these different domains of measurements together and see what we can learn from them in combination. So here at the top of the slide, we have the same sort of plot from the previous slide, but here it's data from all of the performances. And the bottom graphs refer to fin created, representing the patterns of inhalations and exhalations, also averaged across the performances.
Yeah, this is representing who is in what phase of the respiratory cycle when. And so the peaks represent when there's a particularly high concentration across performances and players of the same phase. And we see these peaks in alignment coinciding with some of these onsets. So for example, there's a peak in high flow inhalation with many of these onsets in a way that is way above what we see in other parts of the music.
And so the aim here would be to kind of test the prediction that the string musicians are using their breathing as a way of helping to regulate their timing in cases where timing is difficult to predict. So we don't have any conclusions yet, since we're in the beginning of analyzing these data, but we can say a few take-home messages for you. So first of all, even though we would presume that symphony orchestras play to a consistent quality and they maintain their interpretation across repetitions of the same music. Have I been cut off? Yeah. We see, particularly in the heart rate, that physiological states are varying between performers and across repeat performances. We also see that the dynamics of cellists, sound producing motion are more variable when the rhythmic context is more difficult to predict. And we suspect and we see some preliminary evidence that string musicians might use their breathing to help regulate the timing of their bowing. Thank you.
Thank you so much, Lauren. Finn. I'll just steal the first question here. Finn, those analyses on respiration are awfully cool. How could I ever possibly learn to analyze data like that?
Well, it just so happens that I just published a Python library specifically for analyzing respiratory phase and measurements like this. So maybe since I have a workshop happening in a couple of hours,
At 2:30 in Auditorium 1.
you might have a chance to learn more about the how and the why and the what of that kind of analysis. Amazing. Thank you.
Wonderful answer, Finn, for the very complicated question. Are there any questions from the audience here? Wonderful.
From the perspective of a string player, of course, the onset of a note is not just a change in direction of bowing. That's not required. It's a combination of bow speed and bow pressure. So I was just wondering if you have multi-dimensional accelerometers, whether you could integrate those measures into a bow pressure measure. It might be more closely correlated with the onsets than what you're describing, perhaps.
Yeah, that's a really good idea. This is three-dimensional accelerometer data, so we can try this. Yeah, thank you.
Brilliant. Any other questions from the audience?
Did you look at what happens in syncopations? Maybe breathing is important there.
This is also a good prediction that we can test because we have a lot of music here and some of it is syncopated. Yeah, thank you.
There's a mountain of data they have to sift through still. So they're doing brilliant, actually, because this concert just happened in February. So it's incredible, I think, the amount you've done already.
Wonderful work. Apologies if this is obvious, but at least what I know of string players is a lot of coordination happens at the phrase level rather than at the beat level. So do you have anything to say about that?
I guess initially just part of the challenge here is encoding the musical information in a way that we can integrate well with all of these measures, but that's ongoing. And do you have particular intuitions about movement and phrasing? Respiration and phrasing in string players obviously will be a question. But
yeah, I guess so from what I've looked at so far, this is already a bit of a point of uncertainty for me, how I'm going to actually look at the coordination based on this sensor data, because whereas you can see the changes in bow direction very well at the beginning of a phrase, unless they are already in motion, sometimes it's actually hard to see exactly when they are starting to play, although maybe looking at bowing pressure would help there. So probably this is something we should look into, and also maybe, if possible, taking into account kind of the preparatory gestures.
one of the funny things in looking at respiration is that there's a big difference between players in terms of how often the respiration seems to have a kind of regular alignment with the music, and which suggests that the way in which string players use this kind of thing may be very individual and may be conditional on the role they're playing. For example, if they're concertmaster or first desk, would their respiration actually be part of a kind of communicative strategy that would then make articulation of phrase onsets different than if you're, further back and maybe don't have to worry about that this time around. Yeah.
Thank you so much. We now need to move on to the next presenter, so I welcome Ellen to the stage.